For cell complexes, first we start with torus. This is the simplest structure possible. So you take a rectangle, you have the top side you mark as A, top and bottom as A, and the sides as B. Identify top with bottom and the two sides. What you get is a torus. Note that this is a rubber sheet with the sides A and B. So we get a torus. I'm just going to put some color into it so as to recognize A. We will put a rust color to it, and for B just put a say blue color. Yeah, so that is our torus. Now we want to make after this we want to make a two-hole torus. So the first thing is we just copy what we have drawn above. Yeah, I'm just going to copy it. Yeah. So we have copied B and A. We cut this thing from this corner, that is the northwest corner. Similarly, we draw another torus and we cut it on the northeast corner of C and D. So just right next to the arrow we have drawn on this torus. So once we cut them, we paste them side by side. As you will see now, we just first put the first torus on the side, that is torus with sides A and B, and then torus with sides C and D. General principle is that for genus G, you need to draw a polygon of sides 4G. So for 2-hole torus, we need 4 times 2, 8. For 3-hole torus, we need 4 times 3, 12. So yeah, this is now getting drawn. So yeah, the only thing we need to remember is that C and A are pointing in opposite directions, so are D and B. So that is exactly the point we made the cut. The orientations have to be specific. So that is it. We just now have a 2-hole torus. I'm just going to draw now the holes in it, and now the generators. The generators are pretty simple. This is first I draw A, then C, then let us draw different color D, and finally let's draw B. Similarly, we can draw a 3-hole torus. We just take this polygon with side 8. I'm just going to take a polygon with side 8, just draw C and A, and let us draw the C and A. So the C and A is drawn, and I make just cut right at the corner. Similarly as before, we have to add to it 1-hole torus, and this 1-hole torus has to be added so that C, when glued with E, should point in opposite direction. Similarly, A, when glued with F, should point in opposite direction. And that is we are going to choose the orientation of F or direction of F so as to take into account that F should point away from E. So this is how it's going to look. This is C, this is E, and A is going in this direction, so F has to come in this direction, and that is why we chose the direction we chose. So this will give us a 3-hole torus. I'm just pointing the arrows to show where we exactly cut it and glue it. So now let us draw the 3-hole torus. Yeah, so the general procedure is that we could start with a 0 cell, which is just a discrete set, just a cell like this. 1 cells are nothing but edges and threads, just lying threads, rubber bands, so edge or a thread. And 2 cell is nothing but a rubber sheet. So the general procedure is, for example, in the 1-hole torus, you start with a discrete set, that is just a single point, a 0 cell, attach 2 circles to it, and then we say we fill it. We are not being precise, we just saying fill it with the rubber sheet. You get a torus. Similarly, you take a discrete point, attach 4 circles to it, fill it. Fill it means attach a rubber sheet, like a single rubber sheet. So this is the general procedure. You start with the 0 cell, which was just 1 in both the cases of genus 1 and genus 2, and then you attach 1 cells to it. In the first case we attach 2 1 cells, in the second case we attach 4 1 cells. In all 3 cases we have only 1 2 cell. So if you go on like this, attaching 3 cell 4 cell, you get a CW complex.